All right. Oh, hang on a second. That's probably a little better. Lighting situation, you know. It's important. It's important. Ah, how you doing, stream? What's going on, chat? I'm Agents Ultra. If this is your first time tuning in or just catching my stream for the first time, welcome, welcome. I like to say things twice. Usually just once. Sometimes thrice. Anyway, enough of that. I basically do stuff in Haskell on this stream for the most part. And for the last little while, I've been building a client library for a database called TigerBeetle. If you know what that is, TigerBeetle is a financial transactions database. It's small, lightweight, fast, distributed little database that just does like credits and debits on accounts and things like that. So pretty straightforward. It's got a fairly small API, happens to be written in Zig. We're going to be writing a Haskell client for it. It's got official clients for many other languages, but being a Haskell programmer, you almost never get official Haskell clients and stuff. Haskell language clients, that's what I was trying to say. There you go. So we're doing that ourselves, because that's how it goes. Partly to learn about a little bit about the database, partly to, you know, learn stuff and have fun on the stream, you know? So let's dig in. All right, so we've been working on the like a synchronous version of this client. Okay, so the idea is that, well, let's show an example of the API. We have like this little kitchen sink main app executable I use for testing things out with. So it's kind of what the API looks like. All right, you run sync client, you give it a sync action. Or a client action. And it runs it. And it runs it synchronously. Sync client. So it'll submit the command to the library, which is written in, well, Zig. It's like a shared library. And that library will talk to the server, do all this stuff for you, give you back some data later at some later point. We just wait for that later point. That's what makes it synchronous. And we're almost done with that. So we have create transfers, as we worked on last week. That basically works. And then we're going to get lookup transfers or get transfers. Query transfers? Query transfers, I think. Let's find out. That's in include here. So our TV operations are the different things we can do with the database. Yeah, query transfers is what we're going to do next. We have query accounts, query transfers. The query filter. I think we'll end up using the same struct there. Looks like. And then we'll get probably a list of transfers back. Cool. So let's start with that. It's going to look very similar, I suspect, query counts. So we'll get transfer query. And we'll get a TV response. I'll just leave that in 5 for now, because I'm probably going to get some type errors. Get my builder going. I think I'm in the mixed environment here for it, so it should be there. Oh, whoa, 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 whoa. GHCID, chill out. Okay, yeah, no transfer query defined, so we're going to go define that. And that's up at a higher level. Delta flags probably. Ledger code. Timestamps, limits, and flags. I don't know if we have a ledger ID actually. Maybe we'll just make it in for now. Query transfer code. Again. I'm not sure we can type of that. I think we have one for timestamps. We don't. We will soon. And flags. I think those will be transfer flags, just like the create transfer. I should, oh yeah. Should probably use the auto formatting. I don't know why we have that on this project. I'm just so set in my ways, I guess. I forgot to add EQ and show to these. We should probably add those two over here. Let's go down, chap. Adpex Twin Dog. Back again with another emoji. So hype. Do I ever use the GHCI debugger? No. Not very much. Not very much. I wonder if Emacs's Haskell mode has hooks into that, because Emacs has excellent debugging support for a lot of different languages and debuggers. I wonder. Let's look it up. Mining, rectangular, collapsing. Ah, yes. Well, yeah. Debugging, like I do a lot of debugging on the stream here in Haskell, and it might turn some people off because I tend to use like just print debugging, which isn't the greatest. It's got a debug.trace module that has some handy functions for like adding little trace statements and debug statements here and there. You can do obviously the GHCI debugger, which like I've used, just not that much. I don't know. Debugging Haskell is like just a different experience than like something like C and stuff, which I find debuggers almost not like indispensable, but very, very useful there. But a lot of the time, if I'm like debugging Haskell code, I'm actually just like trying to fix the types or like make some impure code more pure and like remove more code from the impure parts. That tends to resolve things more often than not in Haskell, but occasionally you do need a debugger, it's true. I just haven't used it all that much, so I'm just curious. It's like when I do use it, I have to use it in GHCI, which there is good support in Emacs, at least for me. I'm an Emacs user, where I could just hop into the REPL and start using it. Yeah, yeah, and like I use the REPL a lot, so you could probably use the debugger directly there, even in your editor if you've got support for it. But I'm curious if it also hooks into debugger. Ooh, there is limited support. Oh, okay, cool. Yeah, yeah. Sweet. I should try this more. Right, so you gotta load your modules into GHCI. Do it that, and then I can G to refresh in the debugging buffer. I can set some breakpoints. Okay, cool. You know what? Thanks for mentioning that Apex Twin. I'm gonna check that out next time I need to debug something and see if I can't just go right through this way. That's awesome. Yeah, so you got steps and deleting your breakpoints, getting some context, all that stuff. Sweet. But yeah, so I don't know, that could be useful. I just try to avoid writing, like, you can write a lot of procedural code in Haskell. It's just not the happy path. Right? And depending on your point of view, that might actually be a good thing. But sometimes you really do need it. And so it's good to have that stuff there. So, yeah. All right, query transfer. So we got that type. That's kind of like our input type. This is what the user will be using when creating a query. Okay, so timestamps is not defined. I do have a module for that with a new type for it. We did new type it. Okay, so we just need to import that. All right, and I'm not even using like a super integrated development environment here. Like I do Haskell professionally at work, and I have a much better setup there. Mainly it's just because I'm lazy, and I haven't really like ported that or made that part of it. And also because like the developer tooling for stuff I do at work is probably like overkill for most of my open source work that I do on the stream and stuff. Because the stuff I do at work is like millions and millions of lines of code. Very, very like slow compile times. And so the tooling is designed to make working with a code base that large a bit quicker by trading off some things that I don't normally like to trade off when I'm working on like a library. So it's not the kind of developer environment I want to be using for like working on a library like this, where I don't have a lot of those concerns about code side and stuff. Okay. That's that. We want to jump back to sync. Oh, I added the wrong file. Didn't need it there. I need here. You saw that they worked on that GHCI tool? Cool. So what are you hoping to use Haskell for at work? Just because Haskell and because you like the language, or is there like a particular project that you think it would be really well suited for? so we're going to get our transfer queries. We get the status of running our sync command. I sync submit. Probably transfer, actually. Ah, okay. Trying to generate everything from a single source code base. Your API docs and your TypeScript clients. I would be wary, and this is probably something you know, but for anybody else watching, Servant is a Haskell library for serving web APIs as like a big old type. Let's look at. Oh, their tutorial documentation is down. That's unfortunate. So this library, and the premise behind it though is that like Haskell has like two languages in it. Really, it has a type language, and it has like the term level language. Right. So the type language is stuff like this, where I've got like this little double colon after some definition, and then a bunch of gobbledygook. If you don't know what that is, probably looks like that. But this is like a programming language for programming it in types. Right? And it's kind of like where you specify things about your program to the Haskell compiler. The second language is the term level language. That's everything down here where you're like using actual values and things like that. Separate language. And what Servant lets you do is specify in the type language a type that matches like a web API, like a RESTful-ish web API. And then it can compile out it can spit out the term level stuff to implement that API, whether it's an implementation in Haskell or in TypeScript, an open API spec, and so on and so forth. What I'd be wary of when introducing this to a team that's new to Haskell, that hasn't bought into it yet, is that type-level programming in Haskell is pretty... Like, programming in Haskell is difficult enough to learn, but programming at the type level is like extra. And you can scare away people with it if you introduce this like right off the top, if they don't get it. If they bought in, no problem. Or they're willing to learn and they're happy to because they understand the value prop, great. But be wary that this is going to be an uphill battle if it's a bunch of new people to Haskell and you're the most enthusiastic one and everyone else is kind of like, I don't know. That's going to be tricky. It's tough. It's tough. But it's very, very cool. It's a very cool idea. I think you could do a lot of neat stuff with it. And I like the idea behind it. Like, for example, that's kind of one tiny example of what a query string kind of looks like and roughly what it looks like to write stuff in Servant. But then you have like one place to define all of these things, and then you can generate your everything from it, which is kind of nice. All right, so if you change the Haskell definitions, then you get all your clients updated, everything like that. All right, if you've ever done this with like Ruby and a JavaScript front end, or even JavaScript backend and JavaScript front end, like it's not always in sync with each other, the two parts that you're building. So, kind of cool. Best of luck with that Apex Twin. Couldn't be very useful. I hope it's very useful for you. It turns out really well. You have to tell me how it goes. Back to query transfers. All right, so once we have the status back from the server, we check it. And it's client okay. We await the result. Right, the status of submitting the command. And we await the result. Otherwise, like everywhere else, we just error out. Okay, so that's one part of it. We do need to import this. Transfer here. And what I really like about Haskell, I think I would miss a lot, is this, where I'm just following the type errors. Like, I live for type errors, man. Live for it, and type holes. It's such a nice thing to have. 'Cause I've done, like, refactors, you know, on that big code base at work. And you can just start by just deleting stuff. Right? Just delete it, and you get all these type errors. You're like, oh, God. But then you fix them bit by bit. It starts compiling again. You run the tests all pass again. You write some new tests or whatever just to verify everything. And it's just like so quick. It's so great. And it's like piloting the code base rather than struggling with it. And so I know that, like, if I delete this constructor somewhere in the code base, I'm going to get type errors if I'm using it, right? And stuff like that. It's nice. And I get to know where all of that is. So, it's a small thing, but it's a nice one. Right. So transfer IDs. We need some instances for that. Looks like amount as well. Oops. Transfer query. Loaded scope. Oh, I misnamed it. Cool. So now it's telling me that I haven't created the query transfers function that I call. It's not a scope, so let's go add that. That's not right, is it? What do we want? Oh, sync. All right. Monad.io needs an argument. It needs a thing. Yeah, we have to pass that in. We haven't used it yet, so we should. All right, now it's telling us what, and that's because this type is wrong. So we actually want this to be our list of transfer query, and we're going to return an IO foreign pointer TB packet. Don't need monad.io in there. Apparently we don't need this here. Ah, back to green. Love it. Okie doke. So, now we have query transfers. This has to wrap the lower level stuff to create this TB packet and wrap it in a foreign pointer. So we take our transfer queries. We're going to map what, like a pack. How do I do it for account queries? I just go direct. Probably right here as well. So lift IO, the raw layer is what we're going to call. Query transfers packet. Create a new foreign pointer around that TB packet pointer so that it gets quote unquote pinned in place in memory, so it doesn't get garbage collected until all the scopes that it's referenced in are gone. So that the C library, when it goes to read the data, is going to find it. Right, now it's like, what? This doesn't exist either, and now we got to go implement that. We called it query transfers packet. All right, GHC now is like telling me, oh, this isn't the type. And I really like that too. Pointer to TB packet. All right, don't have that in scope, so let's bring it in scope. And now it's in scope and we're all good again, except we haven't defined this yet. So let's define it. And just like account transfers. No, queries. Yeah, same thing. We're going to pack a bunch of these, getting a data size and an array. I'm going to allocate the packet data and then return that. Probably a bunch of this. accept in case of accounts. Transfer. Now at the pointer, yeah, that looks good. TB packet data accept query filter, yep, that's fine. From, that's not fine, that's going to be transfer. And transfer here. Now the operation is going to be query transfers. That's going to be okay, otherwise the same. Now pack. It's a little language extension called lambda case. Just has a little syntax nicety. Okay, and query filter is not in scope. That comes from our internal query. Then we need data.set. This here is going to be our probably transfer query. Let's look at the internal FFI for transfers. TB transfer flag, probably. So we'll have to define transfer query flag. Not defined. He's going to be way back up on the API side of things. Like account query flag, only we're going to define them for transfers. And what do we have here? Linked, pending, post pending transfer. Basically the same. I was waffling last week when we did this about whether and we should have naming like qualified internally in the library, so we avoid name clashes, because we can't have two constructors in the same module name the same thing for two different types. Like right now we're getting multiple declarations of linked. In fact, almost exactly the same. Yeah, actually we don't need these. It looks like we use the same transfer flags, perhaps. Okay. So transfer flag. And we just need all of these cases. Pop, pop, pop all those. Okay, and then we're getting more ambiguous occurrence things. And that's because we're going to need to qualify. But we can maybe import some of the types. And let's see, 112 here. Not in scope. That's probably just need to import the constructor for that TV query filter. That should be coming from there. Oh no, oh, get account code. Account code here. Is that what I want? Yeah, probably not. Oh, this is gonna be from our, yeah, our transfer query thing here. I guess we do have new types for that. Code. Maybe we need one for transfer code. Or maybe it should be account code. This one should be query. Transfer. Other transfer. This should be query. We gotta get timestamp into scope. All right. To new type or not to new type. Just TigerBeetle treat account codes. Are these account codes on transfers? That's what I don't know. Like it just says UN16T code. And if we're using them for the same struct for both query filters, it sounds like maybe code is its own like thing that's common but unique to itself. It's not like account code, it's just code. The same with ledgers. Excuse me. Fresh pressed juice. Love it. Okay, yeah. I'm gonna do that. I'm gonna make it code.hs. Actually, you know what? I'm just gonna hit this green again, and then I'm gonna do that as a refactor step. Oh, what did I call it? Okay. I'll just smack a little to-do on there. Right. So now these we gotta fill in with our TB query filter flags. I think those come from client. What's wrong about that? Okay, so query. Maybe we don't have that fully implemented. First. Oh, but that's it. That's all. How? What else would it be? I thought they would probably be transfer flags. TigerBeetle documentation. I want to know. Oh, that's it. Literally the same, just reversed. Whether the results are sorted by timestamp chronological or reverse chronicle. Okay. They're not like the filtered by these flags on the transfer itself. That's what I thought. That's what I was thinking that meant. But okay. So This doesn't make sense at all, actually. And it might not for the account as well, so we might need to fix that. So these, yes, for creating transfers, but for querying transfers, just reversed. Maybe they'll add other ones? I don't know. Don't know if we need to leave room for that. Doesn't hurt. Let's make this transfer query flag. Call it transfer query flag. And then this. Just has to be reversed and something. And we import them in qualified here, so that's going to get ambiguous if I put reversed here. Oh, I don't import them. Okay, I just have to type there. So I should be able to internal by query. I can't type on stream for some reason sometimes. Oh, I qualified it. Yeah. Okay, back to green again. That's good. Let's do a little committee commit now. I think we're getting a bunch of code up here that commit's getting a little fat. In a good way, but just getting too much. Too much code. Query transfers command, yeah. Raw, or the high level structure, then the raw level stuff. We still have to do the response. Okay, work in progress. I mean, we'll squish it all down to one big commit anyway, probably. But I just like to work in like tiny little steps so it's easy to back out of things as I go. one. This one's just a little bit wide. Query transfers command. Okay. So let's do this refactor here. Or that's going to affect a bunch of other modules too. Let's save that for last. I'm going to finish where we're going right now because we still have to do the response parsing. And then we'll do the refactor so that I can have like maybe 2 separate commits for that. I'll squish down this response into what we have so far. So in decoding the response, we're matching off of the packet operation there. So we want to get a similar setup here. We have the number of results. We take the result len for the size of TB transfer. Reverse the number of results. For each index, we're going to cast from that word 8 array to TB transfers and create a query transfers response of our result array. Looks like we're golden there. Decoding? Maybe we'll call it decoding. Okay, let's try out this command, I guess. We're gonna need, let's see, we done that, that's fine. We're gonna need transfer. And I don't know if we have any transfers. I think we have some transfers in the system. Let me double check. Let's go projects, TigerBeetle HS. I'll just start up the database, give it a little query from the REPL, and check that we got that. REPL. What do we got examples of here? Create transfers. Get account transfers. I don't know if we have any actually. Right, because we created all the accounts with 0 balances. And the whole point of a database like this is that you can't like destroy money. Right, you can't destroy balances. You can only transfer things. So if I create a source account with some amount, I can transfer from that into one of the accounts we've created. So So I just want to create it on the same ledger with the same code and a balance. I'll give it the special ID of 100. Code 10, ledger 700. Credits. Can I give it credits posted? I'll give it 100 credits. And then flags. Put a space in there, maybe. Linked event chain open. Failed to create account. How do I close the linked event chain? Tell me. Linked events. Events within a request succeed or fail independently unless they are explicitly linked. When a linked flag is specified, it links the outcome of a transfer or account creation with the outcome of the next one in the request. These chains of events will all succeed or fail together. The last event in a chain is denoted by the first transfer or account without this flag. Oh, okay. Okay, and the last transfer account in a request may never have that flag set. It will leave the chain open-ended. Attempting to do so will result in the link chain event open error. Okay. Okay. Credits posted must be 0. Okay. Good to know. I guarantee. So your accounts are immutable. They're never modified once they're successfully created, excluding balance fields, which are modified by transfers. There is at most one account with a particular ID. The sum of all their debits pending is the sum of all accounts credit pending. The sum of all accounts is debit posted is the sum of all accounts credit posted. Cool. Let's look at data modeling. Right, ledgers partition your accounts. This is all good stuff about what you would expect. In financial applications, if you don't know, never try to use floats. Always try to store in like the unit currency in like an integer amount. And then rescale, yeah. ID, da, 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 da. Kaguziha. I hope I said that right. Kakauziha. Thanks for the follow. You rock. It's a good decision. Okay, in code. Yeah, so it's an identifier, represents the Y for an account transfer. On an account, the code indicates the account type, such as assets, liabilities, equity, income, expenses, subcategories within those. And on a transfer, the code indicates why a given transfer is happening, such as a purchase, refund, currency exchange, etc. Yeah. I haven't really mapped out my codes, obviously, as I'm just testing things out here. Transfers. How do I build one? Go single phase. To have a debit account ID, a credit account ID, an amount, no pending ID, optional none, ledgers required, codes required, don't need linked, don't need pending, pending should be false, 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 everything else is optional. Optional, what is maybe imported? Check some of these flags. Flags imported. When set, allows importing historical transfers with their original timestamp. TigerBeetle will not use the cluster clock to assign the timestamp, allowing the user to define it, expressing when the transfer was effectively created by an external event. Domain system invariants regarding auditability and traceability, some constraints are necessary. It's not allowed to mix events with the imported flag set and not set in the same batch. The application must submit batches of imported events separately. The nanosecond since Unix times epoch. No two objects can have the same timestamp, so they must be unique. User-defined timestamps must be a past date, never ahead of the cluster clock at the time the request arrives. They must be strictly increasing. Can have a timeout. Okay. So how do I create a transfer? How do I create an account with a balance? Retransfer ID to debit account ID. Let's do it on one. Credit account ID. Let's do it on one. Amount. 10. Pending ID. We don't need to specify that. Timeout none. We need ledger. 100, I think it was. 700. Code 10. Don't need linked. Don't need those. Anything else? Oh, it needs to be create transfers. Sorry. See, accounts must be different. Of course. Debit account 100. Credit account 1. Oh, 10. Okay, there we go. That's how we do it. And then the 100 account will always go into a negative balance. So we then go get our lookup accounts, lookup transfers, get account transfers, account ID 1. We got 1. Okay. Cool. Super. Okay, so that all makes sense. So we can query transfers here. Let's do the same query. Ledger 700. Timestamp min max will make those 0. Limit 100. M empty. Okay, and then we will run it and see what we get. That's not what I was hoping for, because we haven't imported it, maybe. Transfer query. Oh, we ordered on that. It's going to be an actual timestamp. And timestamp. Okay, well, let's see, call stack error. Oh, interesting. Cannot, transfer flags. Cannot match a 0. What we're trying to... What's the problem with that? Yeah, I think that's probably me doing silly things. 53. Minimum of TB transfer flags. Yeah, and that's because when we're packing this, I think... That's fine. 2 enum. So we're trying to get a result here. TB transfer flag. We go to response. Yeah, we're kind of... Oh, okay, yeah. We're casting this wrong. There's got to be... Oh, 12 TB count. Why? So we're casting out the results here. We're trying to convert it to a TB transfer struct. Okay. That is here. Here. No. Here. And it's trying to get us this transfer flags. This set of transfer flags for us. And in the storable instance, when we go to peek at this, we call this unmarshal TB transfer flags. By peeking at the struct, the flags field of the struct on our pointer. And we call this bitmask to flags function on the word 16. Is it a word 16? Interesting. Yeah, it is. Okay, cool. So we call bitmask to flags. Which comes from this little internal library here. Okay, so we get our bitmap B, and we return set of A as long as we have an instance of ord and enum on A. And so this code here is creating a set from a list. Where the flag is enum from to enum 0. Such that test bit this function here, where its first argument is going to be int and the second one is going to be b, finite bit num b. We're going to come from enum flag. Interesting that that's const 0 though. And also those. I think the reason why that might be an issue, maybe, is that those aren't. Are those values? No, they're bit masks. In the C code, they're bit masks. So this is the shift operator here. So this is just saying, like, transfer linked is the first bit in the uint16. TB transfer pending is the second bit, third, and so on. So this tune enum instance const to be transferred linked. See, I don't think those are necessarily going to be defined like that. How do account flags? So I know those work. They do similarly? They do use flags to bitmask and bitmask to flags. But in TB client, they are also just shifts as well. Flags, but we don't have an instance. TB count. Yeah, we don't have an enum instance on it. Maybe that's what's causing the problem. So if I get rid of that, do my problems, would that go away? Yeah, sweet. Oh no, it doesn't. Dang. Okay. Oh, we just derive it. Okay. So we just need to define it for the transfer flags as well. Restart GHC forks. It's yeah. GHC ID doesn't seem to pick up on changes to transfer HSC files because like it has to do GHC has to do a bunch of extra like compilation steps to translate the HSC file into like C code, compile that back, which generates Haskell, all kinds of stuff. So GHC ID doesn't always pick up on that. So sometimes when you change an HSC file, you have to like restart it. But it looks like that's all good now. Okay, so let's try running our example client again. Cool. And we got it. Just like the client. Sweet. And this change mainly fixes the enum deriving on the query flags. Okay, so let's squish all that down. Reword the commit. So that's going to add sync query transfers command. That's going to go under changed. Cool. And then let's do that refactor. Getting close to end of time. No, I think that was in sync. It was in transfer. Oh, where did I put it? There. Here, I wanted to move code up into its own concept there. So let's do that. I'll call it a new type. Okay, code. Oh gosh, happened to me again. Hands are like, I want to go fast. I know how to go fast, but I don't know what it is. But like when people watch me type, I'm like, I can't. Okay, so we will just wrap that into word 16. I want to go and look in client account. So I want to replace instances of code, account code, with just code. Although, maybe we should have separate types for it. I mean, TigerBeetle doesn't seem to discriminate them, but if you look at the documentation, if we looked at the document, when we looked at the documentation for code, it was like, for accounts, it means the category, right? As an example, you might use codes 100 to 3340 to indicate asset accounts in general, where 1001 is bank account and 1002 is money market account, so on and so forth. When we looked at transfers and we looked at code, ledger code, this is like kind of something else, right? It's an enum denoting the reason or category of the transfer. Yeah, it's still represented by 16-byte integer, or 16-bit unsigned integer. Yeah. But it's not, it doesn't mean the same thing. So maybe we should keep it separate, like account code and transfer code. Like this. Rather than code. I think I'm going to do that. Let's go into transfer then. I will create a new type here called transfer code. That's a word 16. And so here we can replace it with transfer code. Right, and I'm going to show you what I mean by what I said earlier, that like I just love Haskell, like refactoring Haskell code, because you can just dive in and just start changing stuff. And then just follow the type errors until you're green again. Alright, so here we have like, oh, is it ambiguous? So like, what do you mean? We have to have a word 16, right? Okay, cool. Transfer. And then here, it's not from integral anymore. There. No problem. And that way, users aren't going to mix up account codes with transfer codes in their when they're using this library. So types won't let them. So this one will modify mainly there, I think. Added transfer code, new type, changed. The transfer query. Oh, create transfer code. Command. to use transfer code. Updated. Create transfer. Boom. Hey Alice, what's going on? Nice to see you. Welcome to the stream. We're just about to we're just wrapping up and cleaning up some of the code for this TigerBeetle database client. We have the sync version of the library done, so you can issue all the commands synchronously. Once this gets all cleaned up, I'm going to start adding the async version of that so that you can take advantage of Haskell's incredible multi-threading capabilities. Sync just to get you used to it, get to everything set up and kind of working, and like so you can test it out and try it out. Yeah, STM. I love STM. Oh. Just so good. Lovely. Beautiful. Yeah, same. Like, if you're thinking about using a Haskell, like, you gotta be like, do I just like functional programming? Well, you can do that in a lot of different languages. Do I like the types? A lot of languages have types these days. Some of them are pretty good. Haskell's is great, but I think the main thing is like Haskell's runtime and the multi-threading in the STM library. It's super nice. It's kind of like the reason. Or a very important one anyway. Yeah. Not many languages have higher counter types, true. Yeah, the type system's pretty nice. I'd say that's like number 2. Maybe number 1. It's up there, you know? Okay, so transfer codes are different than account codes. I'm glad we separated those, even though they're represented by like unsigned ints and like are used. The word code is used interchangeably in those two different contexts. That feels good. Ledger IDs, should probably also new type those, and like let's just keep with that convention. And we'll go new type, ledger ID. That's going to be a word 32, I believe. How much Rust are you writing these days, Alice? Are you working on any cool libraries or projects? So now that we have this ledger ID, and where I see int here, I could just ledger ID it. Oh, and I love it. Look at this type error. It's like, oh, you didn't know. I know exactly where that is. And even if I didn't, I was just doing this refactor. Like, I know I gotta go change that here. Super nice. So yeah, client transfer. Right here. I'm sure lots of, like, it's such a small thing, because, like, lots of languages have that kind of type level analysis that it would catch things like that, but I don't know. Haskell has ADTs, and it catches them for those too, and various other things. It's pretty nice. Alright, so we're back to green again. So that works, but we should also do it for accounts. Because counts also have ledger IDs, and they get used a fair bit. Okay. So we use account code, ledger ID. Account ID, account. This is limit. Account code, that's good. Use ledger ID here. Limit's fine. Cool. And then yep, not in scope, of course. These are both going to get updated. Ledger ID and account code. There we go. Boom. Nice little commit for that. Add, what do we do mainly? Ledger? Ledger ID. Yeah, ledger ID to account. Oh, no, this isn't right. Hang on. We're missing you. Yes. Yeah. And yeah. Good. Benign deflation for jazz here. Banned. Nice try, though. You're reported to. Always. About once a stream now, at least. Yeah. So add... When applied, this change will add ledger ID. Added. Erase TigerBeetle. Sure. Changed. Count. Transfer. Cool. That looks good. And is there any little things we can do? We've only got a few more minutes left. I mean, there's going to be a fair bit of other stuff, but you know, I'm feeling pretty good about it. Let's push this up. Boom. Okay. There you go. That's what I got for tonight. So, thanks for tuning in and hanging out with me. It's been a pleasure. All the code you've seen tonight is for TigerBeetle HS. It's the Haskell client for the TigerBeetle database. It lives on GitHub. I'm Agent Ultra here on Twitch, on GitHub, also on the Fediverse as well. So I'll post that link in chat there for you. Come check it out. Give it a star. follow, whatever you want. And check it out. This is the sync version of the library. We're nearly done. We've got all the commands implemented now. We're just cleaning up and refactoring and then getting ready to add the async version of the library. And I think we might be able to cut a 1.0 after that. So, I'm on the Fediverse, on Mastodon, on the types.pl server. You can find me at Agent Ultra there as well. It's got links to my website, agentultra.com. My YouTube channel where I back up the VODs for this stream in case you're watching in a different time zone or you want to catch up on old ones or whatever. My Twitch and everything else. I usually post about tech stuff here and try to content warn about anything else where I can, and I remember to. So follow there for updates. I do these streams about once a week on Wednesday evenings at 10 after 8 in the Eastern Standard Time Zone. So if you're on Twitch here, give me a follow and set your notifications up and you'll get notified when I go online and stream. Sometimes I do surprise streams every now and again. You'll get notified of those, or just show up next week and, chill. And if you're on YouTube and you're watching from there, you know what to do. Just give the like and the subscribe, a little thumbs up, leave a comment, and let us know that you're watching and what you like, and maybe tell me about your other projects. Also, there's a link above my head to the declarative.tv website. There's a bunch of other streamers doing stuff in all kinds of declarative style languages, of which Haskell's just one. You can find other folks doing stuff in Erlang and Elixir and all kinds of things. So give it a check, or check it out. Give it a browse. I don't know what people are saying these days. There's also a link to a Discord server on there where we have a channel for this stream as well. So you can hang out there, ask your questions that you didn't want to ask on stream or you didn't have time to or you weren't around for. Or just, show us your projects, ask your questions about Haskell in general, whatever the case may be, it's there. And we're always happy to see new folks join the community. So with that, I will bid you adieu and good night. And wherever you are, may your monads be free and your types always check. And happy hacking out there. Take care.